All right, Unit 8, Lesson 1. So we're going to pretty much just dive straight into examples because in this particular lesson, well, the first two or three lessons actually in this unit, we're not really learning anything new. We're just using stuff that we learned previously, some of which dates back to like middle school, and we are applying it in new context. Let me show you what I mean. Let's look at an example. So we're going to simplify this, and we're going to write the conditions in which the expression is undefined. So I'm going to pause for a second and make sure we see what's going on there. So where is this expression undefined? What can we not have in this? So I'm going to take a step even further back and say, what is that? Oh, that's my cursor. I got scared. Something was happening. Didn't know. Anyway, sorry. What is a rational function? What is a radical function? Well, not radical. That's different. What is a rational function? What is a rational number? Rational number is anything that can be written as a fraction. So rational functions, rational expressions are fractions, right? Things with fractions that we got here. What can we not have in a fraction? We cannot have the denominator be 0. And so here pretty soon we're going to figure out when this denominator would be 0. That's going to be pretty easy peasy. And that's going to be this second part of this question. So how are we going to tackle this? Well, bells should be ringing in your ears, right? We've got some quadratics happening, and we've got like a difference of squares happening, all this stuff. So you probably should be already kind of thinking, oh, maybe I should do some factoring. And if that is what you're thinking, that's exactly what you should be thinking. So we're going to factor these things. So let's factor this top one. We've got a trinomial. What's going to happen to that 5x? He's just going to hang out, right? So the 5x is just going to hang out there. And then for this trinomial, how do we factor that? We'll do two sets of parentheses. We'll open, close, right? Two things that multiply to get the first term, so x and x. Two things that multiply to get the last term, so 5 and 1. Can we add or subtract 5 and 1 to get 4? Yes, we can. Minus, plus. But does the sign work at the end? It does not, because a positive times a negative is a negative. So that doesn't actually work. And the reason it doesn't work is because I copied the problem down wrong. This should be a 3. So good try, but no, this should have been a 3. Hope you got your whiteout or your eraser going, because sometimes that's a thing. All right, so how about 3 and 1? Can we add or subtract those to get 4? Yes, we can if we do plus and plus. Now positive times positive is positive. Now it works. Great. We factored the thing. Now in the denominator, we have this that we can also factor. This one's good to go. This x minus 6 is as factored as it's going to get. This is a difference of squares, right? That's easy peasy. So open, close, square root of the first, square root of the second, plus and minus. So now what we want to know is there anything, now that we got this factored, is there anything that we can cancel? Well, there is. There's an x plus 3 here and an x plus 3 there, right? And so we can cancel those out. So our final answer for the simplified is going to be 5x times x plus 1 over x minus 6 times x minus 3. Now you notice that I've left this in its factored form. We could distribute this back out and get kind of a polynomial expression on the top and the bottom. It's best practice generally to leave things in their factored form until there's nothing else you can do with it, because of stuff like this where you can cancel. So this is the simplified. Now we need to figure out what conditions the expression is undefined. So in order to do that, we need to just set the denominator equal to 0 and then solve for x. So x minus 6. I'm going to go ahead and, since we already did the factoring, I'm going to go ahead and write the factored version of that. That's going to save us some time and trouble. X plus 3 and x minus 3 equals 0. And we want it to not equal 0, right? So now that we've got completely factored and equal to 0, we just set each factor equal to 0. And you've got enough practice at this, you can probably already look and say that, like if this one was equal to 0, we would just add 6 to both sides. So x cannot equal positive 6, negative 3, and positive 3. Negative 3 from this one, positive 3 from that one. You could also write this in a abbreviated notation. I think that's a great plan. So 6 cannot equal 6 or plus or minus 3. Right? So those are the answers to the two pieces of that equation. Let's do another example. We've got several examples that we're going to go through. Oh, this one I don't know what I was doing in these first couple examples. Let me finish copying this example. So for what values is this mess undefined? So this is kind of like what we just did, but even simpler, because all we really care about is where it's undefined. It doesn't ask us to do any simplification or any of those things. So all we got to do is set the denominator equal to or not equal to 0, right? And see what we get for x. So 4x times, I'm going to go ahead and move into factoring this. Let's do it. Open, close, not equal to 0. So two things that multiply to get the first term. So x and x. Two things that multiply to get the last term. So we could do 8 and 1, or we could do 4 and 2. And so hopefully you're getting practice enough to where you can see, oh, that's probably not going to be 8 and 1. That's not going to work. But 4 and 2, 4 plus 2 is 6, right? So, and the end sign works. Positive times a positive equals a positive. Great. Set each one of these factors equal to 0. So this one is going to be x does not equal 0, right? Not equal 0. And it does not equal negative 2, right? We set that equal, subtract by, oh, I don't know why I wrote 2. My brain's jumping all over the place. Negative 4 or negative 2. I guess I could have left it. But so it matches for your notes and things and whatever else. Just good connection there. So let's do another one. We're going to simplify that. Okay, so we're looking at this thinking, okay, nothing quite matches. We can't do any canceling. So let's try to do some factoring. So does this one factor? Yes, it's got W's in common. What about this one? No, nothing factors. What about this one? No, nothing factors. Okay, so let's focus on just this one because it's got W's we can pull out, right? So in the top, we're going to pull out a W out of this one, and then we're going to write down what's left. So when we divide a W out of 4W squared, we're left with 4W. We've excuse me, pull a W out of negative 3WY, we're left with negative 3Y. And then just bring everything else down, times W plus Y over 3Y minus 4W times 5W plus Y. Now, like, okay, because does anything cancel? No, not quite, right? We're still stuck, right? Nothing quite matches. But if you take a look here, this one and this one are almost the same, right? If I was to rewrite this bottom one and flip the order, it would be negative 4W plus 3Y. So it's the same as this, but with flipped signs. How can we do that? Well, we could pull a negative 1 out, right? So we can pull a negative 1 out of that denominator down there. So on the top, we're going to have W times 4W minus 3Y times W plus Y over, now we're going to pull out a negative out of this bottom one and turn it into 4W, positive 4W, minus 3Y. And then the 5W plus Y. So now these actually do cancel. This one and that one actually cancel. So leaving us with W times W plus Y over negative 5W plus Y. Again, we're going to just leave this in the factored form, depending on what we're going to use it for later. That may or may not be what we want. All right, let's do another one, or another two, actually. Simplifying this. So, how do we multiply fractions? We multiply fractions straight across, right? If we have 1/2 times 3/4, we multiply straight across, and the answer is 3/8, right? That's how we multiply fractions. Now, we also, if you've taken some of my earlier stuff, like middle school stuff, then you're probably very familiar with this, but we can also pre-reduce our fractions. So, with a number example, if we have, let's say, 4/15 times, let's say, 30/40, we can pre-reduce this before we multiply. So we can reduce like these by 4 and turn this into a 1 and this into a 10. We can reduce these by 15 and turn this into a 1 and this into a 2. And then 1 times 2 is, we can pre-reduce some more. 2 and 10 is 1 and 5, and turn this into 1/5. Because 1 times 1 is 1. 1 times 5 is 5, right? So you can pre-reduce. We're going to do the same thing here, basically. You can either pre or post-reduce, but pre-reducing is letting us have some smaller numbers easier. So up here, let's see what we've got. Can we do any reducing? Well, we can reduce this 6 and this 8 by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. What about the 15 and the 5? We can reduce those by 5. So 15 divided by 5 is 3. 5 divided by 5 is 1. Now, does any variables cancel? Well, we've got C's on the top, so that don't cancel. We've got A's only on the bottom, the denominator, so that doesn't cancel. But what about our D's? We have a D here and a D squared here. So remember, now you can think about this one of two ways. You can think about this as D. This turns into D times D over D, so one set of the D's cancel. Or you can think about it as if we have like bases divided, we subtract the exponents, and 2 minus 1 is 1, right? So either one of those ways, one of these D's on the top cancels with this D on the bottom. And so what we're left with, we've got to multiply our numbers. What we're left with is 3 times 3 is 3. C times C is C squared, and D doesn't go with anything, so it's just a D over 1 times 4 is 4, and there's nothing else to multiply letters, so it's just an A left in the denominator. Easy peasy. Now, how do we divide fractions? Well, we multiply by the reciprocal of the second one, right? So we've got to first flip this second one over, and then we're going to multiply. So let's do that first. So 18 times xy cubed over 7a squared b squared times, going to turn into multiplication, right? We'll flip this one over. So put the 35 on top, a squared b over 12x squared y. So let's start with the numbers. So we've got these two that can be divided by, let's see, what's the biggest thing? 9 doesn't go into both. 6 does. 6 goes into both. 12 divided by 6 is 2. 18 divided by 6 is 3. What about these numbers? These are reducible by 7, right? Because 35 divided by 7 is 5, and 7 divided by 7 is 1. So now we took care of the numbers. Let's look at the letters, right? So we've got a squared and a squared on the top and bottom. So those cancel completely. Now, this y, we've got 3 y's here and 1 y here. So one of these y's will cancel with one of those y's. So that'll turn into a squared, right? So again, you could think about it that as 3 minus 1 equals 2, right? So you're using our exponent rules. You can think about it either way. Now in the denominator, we've got 2 b's and 1 b. So 1 b will cancel with one of the b's down here. X's, there's an x on top and 2 x's on the bottom. So take out one of those x's with this x. Now let's see what the carnage has done, right? 3 times 5 is 15. And then what else is on the top? A y squared is on the top. I don't know why I drew this big old long thing. We're not going to need that. That's everything on the top that's left after we've killed everything else. So 1 times 2 is 2. And then there's a B left. And there's an X left. Easy peasy, lemon squeezy. Let's do another 1 or 2. All right, now this is the same thing. It's just scarier. I probably flipped to this slide and your eyes went like, ah! It's not that big a deal, guys. It's really gonna be okay. So we're gonna kind of combine what we did at the beginning of this lesson with what we just did. We're gonna start out, because we got all these quadratics here, by factoring them, right? We're gonna get more and more practicing with factoring. This is one of the reasons why the TSI, the entrance exam, college entrance exam type thing around these parts, has a lot of factoring on it, because it's just used all over the place. So we're going to factor this top one up here. 2 sets of parentheses, open, close, open, close. Options for 16 to multiply to get 16 are 16 and 1, 8 and 2. Oh, that looks promising. Or 4 and 4, right? So 8 and 2 look to me like we're going to be able to get a 6. Now we want to get a negative 6. So it's going to be negative 8 and a positive 2. Double check our last sign. Negative times positive is a negative. Great. Now let's factor this guy. Open, close, open, close. X times X is X squared. For this one, we've got 64 and 1. We've got 8 and 8. Oh, look, 8 and 8 is going to work, right? 8, 8, negative, negative. Oh, that's already going to cancel. I'm going to keep on going with the path we're on, but that's exciting, right? So, does the sign work at the end? I didn't double check that. Negative times negative is positive. Great, works fine. X minus 8. Now we're going to factor this denominator. Open, close, X and X. Now this is the one, or one of the ones that's a little tricky, because we could use 6 and 1 and do minus and plus, right? And that'll give us the negative 5, but a negative times a positive is a negative. So it doesn't work with that one, even though it kind of looks like it does, right? We've seen that before. So what about 3 and 2? And then minus and minus. Negative times negative is positive. Now it works. Now let's see what cancels. This is the fun part, right? X minus 8 cancels with X minus 8. X minus 8 cancels with X minus 8. And write down what's left after all the carnage. After all the carnage, we've got an X plus 2 left. And we've got an X minus 3 times X minus 2. Blamio. All right, so now we've got a division one. How do we divide fractions? We flip the second one and multiply. Easy peasy. I'm going to do the same thing, but when I flip them, I'm going to go ahead and factor and flip at the same time, because I think we can handle that, right? So this top was the difference of squares, right? So open, close, square root of the first, square root of the second, plus and minus. The denominator is not a trinomial or a difference of squares, but there is a common factor. We can pull out a 12, right? So pull out a 12. What's left in the first one is just y, and then what's left in the second one is a 3. Then we're turning into multiplication, and we're going to flip it. Now, if you're going to do this and you're going to smoosh these steps together, slow down enough to realize that you need to put this one up here. You might even grab your color and like highlight your extra colors. That way you're kind of keeping things in order. I may even do it with the colors just to make sure we're not making mistakes. Sometimes if you try to do too many things, that's where we get mistakes. But if we have some systems, then we can often make it work. So I'm going to do this denominator up in this numerator. So open, close, y times y gives us y. Oh, look, I forgot to close that thing. There we go. And for 18 and 1, or 9 and 2, not looking promising yet. Oh, 6 and 3, that's going to work. 6 and 3, negative and positive, because we want a negative 3. Negative times positive is negative. That's all working out great. I'm going to change to my yellow, so it's going to match this one. Excuse me. So open, close, open, close, right? So x times x gives us x squared for 32. There's all kinds of options. 32 and 1 doesn't look great. So 4 and 8. Oh, 4 and 8. 4 and 8, yeah. 4 and 8. Negative and negative. Negative 4 plus negative 8 is negative 12. Now a negative times a negative is a positive. It all works out a treat. Now let's do some carnage. Do some damage. X minus 4 cancels with X minus 4. That's great. X plus 3 and X plus 3. Wow. Anything else? No, I'm not seeing anything else. Let's write our answer. So after all the carnage, X plus 4 is left. And y minus 6 is left. And 12 is left. And x plus, no, that's a minus. X minus 8 is left. Easy peasy. We got one more set of two things, and then we're going to be out. All right. Now, oh my gosh, your eyes got big again, didn't they? So scary. It's not, though. This is just division, right? How do we divide fractions? We flip the second one and multiply. It's the same thing, just written differently. It's easy peasy, right? So we're going to flip the second one. Now, on this first one especially, I'm going to kind of give you a shortcut. I don't want to do that. I'm going to give you a shortcut. We've got, so when we flip this second one over, this one's going to be on the top and this one's going to be on the bottom. So if we look at our two denominators, if they're the same or can be reduced, then it's just going to cancel. And then there it is. A plus B over. I shouldn't show you doing it a fast one first, but just kind of happened that way. A squared plus B squared. Now, of course, you could rewrite this as A plus B over 4 times 4 over A squared plus B squared, and then cancel, and then you could do all that. Or you could just look, oh, the two denominators are the same. Pfft, extremes over means. Blap, done, finished. Let's do this one. This one I'm going to walk out and do like all the steps, right? We can actually see that X and there's one of these X's is going to cancel and this can factor, but I'm going to take our time and do it. So I'm going to write the top one, X squared over X squared minus Y squared. Actually, let us go ahead and factor that. That's a difference of two squares. Let's go ahead and do that while we're bringing down. So square root of the first, square root of the second, plus and minus, right? Easy peasy. And then times, we flip the denominator over. So y minus x over 4x. So let's start hacking away. So y minus x doesn't quite cancel. We're going to have to pull a negative out of this one, right? I'm going to go ahead and cancel one of these x's. And then down here, we gotta pull something out, or we could even do it in the numerator. Let's do it in the numerator. Why not? Let's pull a negative out of this one and turn this into negative. I'm going to flip the order, so turn it into x minus y. So the y is now negative, and the x is now positive, right? Because we pulled a negative out. And then the denominator, we have just all this stuff left. So x plus y times x minus y. Looky. We can cancel that one with that one now. And turn now, oh no, what's left? This is one of those places that you see a lot of scarinesses, and somebody inevitably this happens on a quiz or test or something. They're like, oh no solution. It turns into zero, or the answer's 0, or that's not true. And let me make sure and illustrate well why it's not true. These cancel. What does that mean? If I have 4 divided by 4, what does that cancel to? That cancels to 1. 4 divided by 4 is 1. X divided by X is 1, right? And so it cancels to 1. So our final answer is negative 1 over X plus Y. That's it for this lesson. This is about what I expected time-wise with that number of examples. We did all right. Hope you're having a great day. We'll see you later. Adios. Hasta luego. Be good and happy and stuff. Bye.